Alright, we're going to do number 57 from chapter 9. The problem reads, a bullet of mass little m is fired into a block of mass big M, initially at rest at the edge of a frictionless table of height h. The bullet remains in the block, and after impact, the block lands a distance d from the bottom of the table. Determine the initial speed of the bullet. So this is a momentum problem, and then it's going to go into kinematics. So we start with momentum initial equals momentum final, and you have the momentum of the bullet, so little m times velocity initial equals, the bullet is going to get lodged into the block, so you're going to have little m plus big M.
No way.
Times velocity final.
Velocity final.
And then we're trying to solve for velocity initial, so we're going to isolate that variable. And you get little m plus big M times velocity final over little m. And so now we have to solve for velocity final because that's an unknown variable. So velocity final equals distance over time, and we are going to get the distance is d, and then the time we are going to get from the kinematic of the block following h distance. So we use the kinematic x equals v naught t plus 1/2 at squared. So there's no initial y velocity. X here, like the displacement, is h, and your acceleration is gravity, so 1/2 gt squared. We're solving for t, so t equals the square root of 2h over g, and you get the square root of 2h over g for your velocity final. And we're going to sub that into here to get the velocity initial. So distance over 2h g, and that is our final answer, except we're going to move the square root of gravity up to the top. You know, good math skills, algebra. So little m plus capital M, parentheses, over little m root 2h, and on the top you're going to have distance times root g. And this is our final